So the first thing you have to do down here was get the formula for the area, and they tell you that it should be x times 40 minus x. So let's have a look at doing that. Five A part 1. So you can call this one here x, and this will be x, and this will be y, and this will be y. And the question says that the farmer has, let's see how much he has. Is it 80 in total? Yeah, 80. Okay. So you know that x plus y plus x plus y should equal 80. So 2y plus 2x should equal 80. Y plus x should equal 40. So y should equal 40 minus x. So that means the area should equal xy. So the area should equal xy. So that's the formula for the area. That's all straightforward. Yeah. Okay. So the second part, find the x that makes the maximum value for the area. So you have area is 40x minus x squared from there. And if you want the maximum area, it means you want to know what value of x will make the derivative equal to 0. Well, I think that's clear. What would the x be? 20. 20 meters. Confirm that your answer is a maximum. So the second derivative is equal to minus 2, which is less than 0, so therefore a maximum. And the last part is to calculate the area. So the area will be 40x minus x squared. So you put x as 20, and you would get 400 meters squared. Yeah. So I think there's probably more to the question, is there? Yeah. So that was compared to other questions, that was a easy practical question. Sometimes they're more difficult. The reason it was a little easier than normal is because we have a B part to do as well. Okay, so we have a cubic, x cubed minus 9x squared plus 27 minus 23. So we have y equals 9x cubed. Thank you. What is it plus? Oh. X cubed minus 9x squared. Yeah. Like this. Okay. And they're asked us, show that there's only one stationary value and find its coordinates. Okay, so stationary just means turning point. The derivative here is 3x squared minus 18x plus 27 equals 0. So x squared minus 6x plus 9 equals 0. So you have x minus 3 squared equals 0. So that means x equals 3. Now we need to find the y. So if I put that back in here, I get y equals, let me see, 27 minus 81, 60 plus 81. Is that right? 81, yeah? Minus 23. Oh, that's nice. That's 4. So the point is 3, 4. Yeah?
Just 1 point?
Yeah. There's only one solution to the quadratic in this one, because the quadratic had repeated roots, x minus 3, x minus 3. Yeah. Sorry? Yeah. Show that it's a point of inflection. I think they made a mistake here. Or if they didn't make a mistake, they're asking you something which they're asking you something which is not really something they should be asking you. So point of inflection is, does anyone remember? Second derivative is 0. But that's only true if the first derivative is not 0. Because do you remember when we drew our table with all the possibilities? The one in the middle had a question mark. What was the one in the middle? It was the first derivative and second derivative is equal to 0. Yes, this is what I was worried about. What I was worried about was that you couldn't use what it seemed like you were supposed to use, which was the second derivative is equal to 0. What you had to use was a graph. Now, that's a little bit annoying. That means we have to draw a graph here. Now, I hope to give you a good few marks for that effort. Oh no, that's the second part. Okay. I'll do it anyways. So before I do it, unfortunately, this one here can't be used because the first derivative equals 0. Now this is a bit annoying because the last time that they did this question in the exam, I said to them, this question is not on the syllabus, and they said, oh, you're right, and then they included it in their practice exam. Unfortunately, the person who writes the exam, like anybody, can sometimes make mistakes. I think really this question is a mistake. They shouldn't be asking you it. But I'll show you what to do when this happens. If this wasn't 0, you would just need to show that this one here is 0. But if you remember from our table, there was one picture we didn't know when the first and second derivative is 0. So anyways, it's an easy way to fix it. All you need to do is take 3 points, a point a little to the left, a point at the turning point, and a point, well, first, let me just confirm that the second derivative is 0, that we do have a problem. So the second derivative would be 6x minus 18, but when I make x is 3, I do get 0. Okay, so we've confirmed we have a problem. So the way to deal with that is we take a point a little to the left, the point itself and a little to the right. So I'll need my calculator here. We need to put in 2.9 and we need to put in 3.1 back into the original. Okay. I don't know what it'll be, but it'll be something a little bit less than 4. It'll be something like 3.9 and 4.1. Actually, I'll just use the calculator here. Now, it's also important to note that different people write the exam. So I can tell that whoever wrote this exam was different to the person who wrote this question last time it came up, because they have a different way of answering it. So the solution that this person offered, I'm not going to do it the way he offered. I'm going to do it the other way, which is a little easier, which is just using the numbers to the left and to the right. My program's loading. Maybe you can type it in. Can somebody type in 2.9 into the cubic and 3.1? Malik, maybe you could do the 3.1. And then somebody will give me 2.9. What did you get? 3.9. Yeah, okay. 3.999. And then this must be something like 4.001. Yeah, as I thought. Yeah. So here, this is a rising inflection point. So what's happening here is this shape here, this is concave, and then this one here is convex. Now, that's not the only way to do it. I said there are two ways to do it for this particular one. What you could have done is you could have calculated the first derivative when x is a little to the left. So, for example, when x is 2.9. And should it be positive or should it be negative? I'm sorry, not the first derivative, sorry, the second derivative. Should it be positive or should it be negative? No, what should it be? Because you know its shape. If it's concave, it should be negative. So if you use this, you should get a negative, and then if you use 3.1, you should get positive for convex. Yeah, so this is another way to do it. Okay. But I think it's just easier if you take a point to the left and to the right, and then you can kind of see if it's an inflection point which is going concave, convex, so that means it's rising, or if it's convex, concave, that means it's falling then. I wouldn't be worried too much about this in the exam. I hope that they don't ask it. They really shouldn't though. I think part 3 is the graph. Yeah. So actually, let me draw my graph, but nicer. Where does it cross the y-axis? At minus 23. Yeah, so here is y, here is x, here is minus 23, here is 3, 4. Oh, here is 3, 4, and then we said it's rising inflection, so it goes up, 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 up. Ugly. Let me start with this part. So ugly. That's a bit better. And if you compare it with what they have in the marking scheme, oh, well, I should really put in as a point down here. So although my graph is ugly, you can see that it's exactly what they have in the marking scheme. So I didn't need to bother putting the numbers on the X and the Y. I mean, you should, but you can see to get the full marks, you don't even need to do that for this question here. So it's just a 2-mark question, not too much detail. I think it's a bit odd that they put the X here and not here. I think so. I usually put my X here, but that doesn't matter. Okay. We have a look at 6 now. Okay.